Section 4.3, Systems of Linear Inequalities. The problems that are going to be worked in this section are found on pages 74-75 of your workbook. So after listening to this video and completing the problems, please go ahead and complete your online homework 4.3. In mathematics, a linear inequality is an inequality which involves a linear function. And recall that a linear function can be written in the form y equals mx plus b, where m is the slope and b is the y-intercept. Now just recall that a linear inequality contains one of the symbols of inequality: less than, greater than, less than or equal to, or greater than or equal to. So these are the steps that we're going to follow to solve a system of linear inequalities graphically. And I will just go ahead and read through these, and then we will apply these steps to the problems that we're graphing today, or the inequalities that we're graphing today. So first of all, given one or more inequalities, we're going to solve the inequality for y first. So we want to make sure that y is alone. Once we do that, we're going to treat the inequality as a linear equation, and we'll graph the line as either a solid line or a dashed line depending on the inequality sign. In other words, if the inequality sign does not contain an equal sign, so if it's just less than or greater than, we're going to draw the line as a dashed line. On the other hand, if the inequality sign does have an equal sign, in other words, it's less than or equal to or greater than or equal to, then we're going to draw the line as a solid line. Once we graph the line, we'll shade the region that satisfies the inequality. And I'll talk about that a little more on the next slide. Okay. Now we need to repeat steps 1 through 3 for each of the inequalities that's given in the system. And then the solution set will be the overlapped region of all the inequalities that we graph. All right, so let's go ahead and use these steps to graph some inequalities. I want to recall that a point or an ordered pair is a solution to a system of inequalities if it satisfies all of the inequalities in the system. Okay? So in other words, if you were given two inequalities in the system, the point would have to be a solution to each of them in order for it to be a solution to both inequalities, or the system of inequalities. And this is what I was talking about when you're shading. Once you've graphed the linear equation as a dotted line or a solid line, y is alone, you've graphed the linear equation. Y greater than means that you will shade above the boundary line. Once you've solved for y, if you end up with y less than, that means you're going to shade below the boundary line. So let's go ahead and get started graphing. Now notice this first equation we're given is not an inequality. We're just given the line y equals 2x. Okay, so recognize it is in the form y equals mx plus b. Okay, so your slope is equal to 2. And remember, slope is rise over run, so we can write that as 2 over 1. And then your y-intercept would be like saying y equals 2x plus 0. So you can see that your y-intercept is equal to 0. So recall that to graph this line, we'll go ahead and plot our y-intercept. I'll do my best to graph this on here. So the y-intercept is at the origin, and then we're just going to, from that point, we're going to rise 2, 1, 2, and run 1. We could continue to do that, rise 2, run 1. But you can see the line of y equals 2x is the line that goes through those 2 points. Okay? It's a line. All right? We're not graphing an inequality. So let's try the next one. Now notice in the next one, instead of saying y equals 2x, we have y is greater than 2x. Okay? So we're still going to graph that same line, y equals 2x to start with. So I'll just put this over here. Okay, once again, our slope is 2 over 1. It's the same line, okay? And the y-intercept is 0. Now, notice y is greater than 2x. Since it's greater than, we need to make it can't be equal to because it doesn't have the line underneath, so we know that we're going to have to graph it as a dotted line. So there's my y-intercept, rise 2, run 1. And I need to graph a dotted line through there. Okay? Please forgive my bad sketches, but I'll do the best I can. All right, now, since it's y greater than 2x, that means the solution to that inequality is anything above the line. Okay, so that's how you would graph the solutions to that inequality. All right, and notice we didn't have to worry about getting y alone first in this inequality because it was already alone. Let's try another one. All right, here we have the inequality y is less than or equal to 2x minus 1. Now notice once again that y is all by itself, so we don't have to worry about solving for y first. Okay, so let's just go ahead and graph the line first. Y equals 2x minus 1. So you can see your slope is equal to 2, which would equal 2 over 1. B, or your y-intercept, is equal to negative 1. Okay? So let's just go ahead, and since y is less than or equal to, we'll be using a solid line for this particular problem. So, boy, I made that 2 look like an exponent. Let me make that just a more solid 2. Okay, so we have a y-intercept of negative 1, so there that is right here. And then my slope, we're going to rise 2, run 1. You could keep going, rise 2, run 1, rise 2, run 1. Recall that if you wanted to get points in the opposite direction, you would do the opposite. You could rise negative 2, run negative 1, rise negative 2, run negative 1, but really you just need 2 points. So when you're doing this in Lumen and you graph your line, it may mark it wrong if you use a bunch of points, so you might just want to use 2 points to graph your line. That will just help me graph it better though, since I'm just using a pen here. Okay, so since y is less than or equal to 2x minus 1, we need to shade below the line. So that's how you would graph that that inequality. All right? Fun stuff, huh? Let's try the next one. Graph 4x minus y less than 5. And notice right away you have a less than 5, so we're going to be using a dotted line when we graph this inequality. Now we're going to have to do step 1. Remember those steps that I went through earlier. We need to make sure y is alone first. So to get y alone, the first thing we're going to do is we'll subtract 4x from both sides. So we have negative y less than negative 4x plus 5. Divide by negative 1, divide by negative 1, divide by negative 1. That's a negative. Be careful though, because remember when you divide by a negative when you're dealing with inequalities, in order to have a true statement, you're going to have to also flip that inequality sign. So we'll end up with y greater A negative divided by a negative here is 4x, and positive 5 divided by negative 1 is negative 5. Okay, so let's just go ahead and graph the line y equals 4x minus 5. We have a slope of 4, rise 4, run 1. We have a y-intercept of negative 5. So let's go ahead and graph that. Y-intercept negative 5. Alright, now we'll rise 4, 1, 2, 3, 4, run 1. Rise 4, 1, 2, 3, 4, run 1. One, two, three, four, run 1. Okay, I'm just going to do the best I can. And oh, I need to have a dotted line. That's a dotted line, okay? I may have been forgetting to put my arrows on my previous lines. I'm not going to go back and fix those, okay? But no, you put arrows on those. They extend in both directions, okay? And now, since y is greater than 4x minus 5, we know that that's going to be the region above the line. Something like that, okay? All right, the next few problems, we're graphing a system, so we're going to have more than one inequality that we're graphing, okay? So if we look at this first one, let's graph the system, y greater than or equal to negative 5, which will be a solid line, and x also has to be greater than or equal to 1, okay? So y greater than or equal to negative 5 and I'm just going to put a little and here, okay? Okay, so that means that we need to see where these, once we graph each of these inequalities, we need to see where they overlap, okay? That will be the solution, okay? And so and, recall, is the intersection of these two, okay? I'll write the word intersection, if I can spell it. Okay, so let's go ahead and think about these just as lines. We would have y equals negative 5, and then we would have x equals 1. So let's just graph those lines to start with, and they're going to be solid lines. Okay, so let's just look at the first one. So y equal to negative 5, we know here's x, here's y. Y equal to negative 5 will go down 5, 1, 2, 3, 4, 5. We just need to put another point somewhere along here. And it's going to be solid line. And so we know, since y is greater than or equal to, it's going to be, we would draw the lines going up like so, right? It would be the region above that line. All right, now let's consider x equals 1. Well, x is equal to 1. Here's a point here, x equals 1, and I'll just do another one up here. And once again, it's greater than or equal to, so we need a solid line. Now, x is greater than 1. We'll be going this way. So you can see the region where those two graphs, y greater than or equal to negative 5 and x greater than or equal to 1, are going to overlap. It's going to be where you see the arrows going here and the arrows going here. It's going to be this region right in here. Okay? That's the region where those two graphs overlap. Okay? So that region that I just shaded is the final answer to this problem. Okay? All right, let's graph this system. We have y greater than x. We'll be using a dotted line for that one. And then we have y less than negative x plus 6, and we'll have a dotted line for that one as well. Okay? So let's go ahead and see where these two linear inequalities will overlap. Okay, let's graph this system. Okay, so first for y greater than x, let's just think about what that line looks like. That would be if we have y equals x, okay, that would be a slope of 1, y-intercept 0, okay. So your slope is 1 over 1, right? Rise over run. So it is going through origin. Rise 1, run 1, rise 1, run 1, rise 1, run 1, rise 1, run 1, run 1, okay? And we need a dotted line. Okay? Y is greater than x, so we shade above the line. Okay? Now let's go ahead and look at our second inequality. Y less than negative x plus 6. So if we looked at the equation y equals negative x plus 6, your slope is negative 1, which equals negative 1 over 1, or you could have a 1 over negative 1. You have a y-intercept of 6. That's going to take me off my little graph here. I'm sorry. But, well, not quite. We have enough room, okay? So my y-intercept is 6. It's right there, okay? And now I'm going to rise a negative 1, going down 1, and run 1. Rise negative 1, run 1. Rise negative 1, run 1. There's a point of intersection. Rise negative 1, run 1. Rise negative 1, run 1. Okay? And since y is less than negative x plus 6, we need a dotted line. And when you're working in Lumen, you'll have to select whether you want a dotted line or a solid line. And since y is less than negative x plus 6, that's going to be the region below the line. And so now you're looking for, in order to graph that, you're looking for the region where the part of the two regions that intersect. So you can see that's going to be this region right in here. So that's how you would graph that system of inequalities. All right, we have a couple more to do. Maybe just one more to do. Okay? I hope you're catching on with this and that this video is helping you. All right. In this example, we have an extra step because notice we need to solve for y first in each of these. Okay, so that's the first thing I'm going to do. Do recognize that we have a greater than or equal to and a less than or equal to. Paying attention to the equal to, just pointing out that we are going to need solid lines when we graph these. So I'm just going to look at my first one. I have 3x plus 3y greater than or equal to 9. Let's go ahead and subtract 3x from both sides. So I have 3y greater than or equal to negative 3x plus 9. Divide by positive 3, positive 3, positive 3. Good. So there's no need for me to flip my inequality because I just divided by a positive. So I have y greater than or equal to negative 1x, right? I don't really need my negative 1. Negative x plus 3. Okay? So in this case, when I graph my line, notice that your slope is going to be equal to, I'll just go ahead and graph this one first. Slope is negative 1, or you can think of it as negative 1 over 1. Your y-intercept is 3, right? Okay, so y-intercept 3. I'm going to rise negative 1, run 1, rise negative 1, run 1, rise negative 1, run 1. Solid line. And since y is greater than or equal to, or greater than, we need to shade above the line. Okay? And now let's go ahead and look at our second inequality in the system. We need to solve for y in that one as well. So we have 4x minus 2y less than or equal to 8. I'm going to subtract 4x from both sides. I get negative 2y less than or equal to negative 4x plus 8. Divide everything by negative 2. I'm dividing by a negative, so I need to remember to flip my inequality. So I'm going to have y greater than or equal to 2x. 8 divided by negative 2 is negative 4. Okay, so let's go ahead and see where we are here. You see we have a slope of 2. So rise 2, run 1. We have a y-intercept of negative 4. And we know since we have greater than or equal to, we need that solid line again, okay? So this line that I'm going to draw first has a y-intercept of negative 4. We have a slope of 2, so I'm going to rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. I haven't gotten any of my points mixed up. Okay, and since y is greater than or equal to 2x minus 4, we know that we're going to shade the region above that line. So you can see that they're going to overlap in this region right here. Okay, so that's how you would graph that system of linear inequalities. All right, so now go ahead and get yourself started on the 4.3 homework for this section. All right, I'll see you soon.